All right, cool. And we'll let you take it away, Hannah.
Great. Okay, recording seems to have started. Let me share my Chrome window. Yeah, okay. Okay, so you should be able to see the slides. I'm presenting without camera because it takes up some of my internet connection and it is a bit unstable. So,
Yeah, we can
my
see
name
it.
is
Looks
Hannah.
great.
Yeah, yeah. So my name is Hannah, and I used to work at Hugging Face. This was my internship project. Now I will start working in Zurich for another project. Unfortunately, not with Hugging Face, but yeah. Also, I did this work together with Baptiste Kohl and Leandro van Vera from the science team in Hugging Face, also based in Switzerland. And yeah, let's dive right into it. So, quick overview over the structure of my presentation. It is not very big, so just start from the original motivation, why we started working on this project. There was a benchmark that motivated basically all of this project and all of this idea. And then scaffolding, which is related to like a very technical aspect of LLMs and agents. So how you can wrap your LLMs into agents. And then next, I will dive into how we actually integrate Jupyter, which is the most interesting part for you probably, as this Jupyter agent and how we wrap LLM into generating those synthetic Jupyter notebooks with code. And yeah, later we generated a synthetic dataset of those notebooks to be able to train some small open source models and make them much better at those tasks. And evaluation is basically the last part where I mentioned the benchmarks and our performance boosted this task thanks to our methods previously mentioned. So let's start now with motivation. This is a bit already outdated slide because Russ also shared this with me last week that Google released a DS star, also kind of like LLM agents for data science. But also Google previously worked even in the beginning of the year on data science agent and Google Colab, already integrated into there. I believe originally it was a separate project and then it got directly included into Colab interface. So it kind of works in a similar way. You can kind of use Gemini assisted coding inside Colab, but this is done usually on cell level. And also Databricks have released, I believe in around September, Databricks Assistant Data Science Agent, which is essentially the same idea. They trained a model to analyze data and to write code to be able to process those data analysis tasks. So we see this very niche, but growing a popularity domain, and we understand this kind of tasks demand more and more code, workforce, and processing time. But using LLMs actually speeds up this process dramatically. But we were interested in the question, what if we try to make this in open source fashion available to people? So we started actually from dubstep benchmark, more like my co-authors, especially Leandro, who is our kind of project manager. He started working on this benchmark, which analyzes large language models and the ability to write the code to process and analyze data. And this data can be in several formats, but usually it's either CSV or JSON files. And then it kind of enables the same setup as we use eventual Jupyter agent, where we simulate the code in a sandbox. We upload the data there, and then we prompt LLMs with a question. You have this data set. You need to analyze it and answer some factual question about it. And you can see examples of such questions on the slide. And the questions that are usually separated into two levels of difficulty. There are easy questions and hard questions. So it's kind of like a double benchmark a bit. We usually split it in easy score and hard score, and you'll see it later. Why? Because easy level questions, they usually are focused on just direct factual information from datasets, which is easy to extract. Get me top 10 products from this dataset, judging by their sales in March. This does not require a lot of code, and you just use one data source for it. But hard level questions are often involving several files, for example, which you need to join or merge in some fashion. For example, there are setups where you have several data sets and you also have appended a README Markdown file with instructions how to interpret and analyze the data set. So for this type of hard questions, the model needs to do multi-step processing of the data sets and analyzing them. So yeah, logically, this is considered to be harder. And actually, this benchmark, the proportion is skewed towards hard level questions quite heavily. I believe there are 3 times more hard questions than easy questions. So this is interesting. And they have a leaderboard available online. It's called the Dubstep Leaderboard. It's a Hugging Face hosted space. And right now the results are already a bit more updated since the DS star from Google Cloud AI Research Update, for example. But in general, you can see that easy level accuracy is quite high, but hard level in most of the models is not perfect. And you can see here, for example, Claude 3.5 Sonnet React baseline. So React is a type of prompting, kind of like multi-step thinking or a bit of a self-reflection, if you think about it. So the model kind of generate code and then check if it's valid code, if it's good for data analysis, or if this code actually works. So if you use in comparison, on the other hand, out of the box models, the same Claude 3.5 Sonnet without any kind of special prompting technique, the results would be even lower. And you cannot even see them in this leaderboard because they're much lower. So we see a clear gap here. First of all, even several gaps. First of all of these high leaderboard results, they require some kind of a special approach or special prompting, some kind of multi-step solution. And then secondly, most of these models are closed source proprietary models. But is there anything that people can actually openly use and host locally on their laptops to be able to run this kind of agent locally if suppose they're working with some sensitive or private data? And this is really important. So that's why we later focused specifically on small-sized open source models like Qwen 3.4b, which is easily hosted locally on your laptop. It doesn't require a lot of memory and it's fast to run. So our main goals in this project were first to integrate models efficiently into data analysis tools and make them able to generate notebooks. And in particularly, this becomes more challenging with open source models since they're weaker than proprietary models on coding tasks. And the format of Jupyter notebooks or Jupyter code in general, data analysis are very unknown topics to those models. Right now, all the model providers, they focus their LLMs on these coding benchmarks, like SV, for example. They focus their models to write really complex algorithm in their code to beat those benchmarks. Whereas tasks like data science or data analysis, which actually require simple code, they're underrated and underrepresented in training data for most of these models. So this is the first task. And then the second task would be to design a pipeline which enables us to kind of convert these small, not really strong open source small models, which you can easily host locally, into this very strong tools that can help you automate this process and save you a lot of time. So yeah, let's move to scaffolding. So you can think of scaffolding as a way to wrap your language model as an agent. A model or an agent which has access to tools, so it is able to call some functions. And the original way, for example, small agents, which is another package from Hugging Face, it's not really efficient in our case because the package is adapted to many use cases. And mostly this would be, for example, computer use or browser use, which requires a lot of installations and imports to be able to use internet and use browser. We don't need that. We host everything locally. And most of these packages become irrelevant. And we see that most of the code is not really efficient. So we took our own scaffolding approach, which was inspired by small agents and Qwen agent in a similar fashion. I believe in Qwen agent, they also kind of tend to simplify things, but we wanted to take it even further. So we shortened our code or debloated it to 200 lines of code. And we removed all the unnecessary external dependencies. So this is really the code designed for this task. to make a model like a data science agent, which works with Jupyter notebooks and with this remote code execution sandboxes. That's that. And using this custom scaffolding, we saw a very surprising result. Our accuracy already jumped by 15% just when we switched to this simple scaffolding, where we just we showed all the necessary information and only that to the model. We said to the model, okay, here's your task, here's your data set. You have two tokens. You just work with that, do not do anything else. And this kind of gives us a bit better efficiency already from the start. And this is a score on Quen 3 4B, which is a small open source model. So we definitely saw room for improvement. Now, the next task was, okay, this is just scaffolding, but we can actually tune a model to be able to work better in those tasks. And we needed a data set for that. And also needed to think about how we can wrap the model into this emulated Jupyter Notebook or Jupyter Lab environment. You can say it like that. So first of all, we wanted to handle just query code generation through LLMs. But for example, all the parsing in UI or user interface was done with the help of our code. But the model only saw this kind of like the data format, which we just provide as a description. I can explain it later. And then just the code and code execution results. So we kind of try to minimize involvement of language model like that, so it doesn't get distracted by these other tasks. And then language model agents, they have just two available tools. One is calling code execution. So we ask the model, write some code. It generates some code, and then it can call this tool and say, okay, I generated this code, please run it in the sandbox. So we run it in this remote code execution sandbox, and then we get the traceback or the output of the code and show it to LLM. And based on this, the model can understand what is the next step. If there is an error, it can fix it. If there is some other next step which is required to do to be able to answer the factual question about the data, it will generate the code further. Once the model decides, okay, I have my final answer, I don't need to generate more code, it can call the second tool, which is kind of final answer trigger. So it says, I'm done, here is your answer. And that's that. Really simple. And we also wanted to, yeah, like I said before, execute the code in a remote sandbox. And we had two options, which is real sandbox. For example, we use Czech startup E2B to provide us with these virtual sandboxes that we can access through API. And in those sandboxes, we already have some packages pre-installed like pandas or NumPy. We can upload datasets there, and then we can run the code there. So all the code execution is being done in those remote sandboxes, and then we get tracebacks to pass to the model to be able to plan next step. In some cases, we did not have, for example, real dataset available. So it was kind of more about hallucination when we generated synthetic data. So we kind of presented the description of the data set with names and maybe column names. And we asked the model to kind of come up with a way to work in this imaginary setup. And then we use another more powerful language model, which is, for example, Quen 3 Coder, which is really good at coding, to act as this kind of like code executioner where we pass, for example, some data set and then pass in brackets. And then we also pass the code to execute, and then the model generates some kind of a semi-valid or a bit hallucinated code execution traceback. In most cases, it looks quite decent and natural, but we understand that it's always better to stick to the real sandbox. However, in many setups, I'll explain why later, we could not actually access the real datasets to be able to upload something as a real data source in the sandbox. And then we wanted to format the generated code and its output in the user face as a Jupyter notebook through packages like in format and in bconvert. Now, first of all, we started with a demo. We just wanted to try a powerful model like Quen code 235 billion and connect it into this setup through Cerebras API. And then I can show the demo here. It is actually really fast. So, for example, I can upload my own dataset. this is my own data set about the level of urbanization in the cities. And I don't even remember precisely what was the format of the data set, but I just want to get like top 10 urban cities, for example. Now we can try and see how it works. And then you can see that we have sandbox timeout. And it is usually roughly 5 minutes, I believe, yes. And then we have a system prompt where we list all available packages which are related to Jupyter, then data processing and plotting. In this version, we do not really work with plots. And then some other packages which are often used for the data processes or kind of package dependencies. And now we can see generated. It can be lagging right now because I have two spaces open simultaneously. There is, for example, if you open the demo, you have a default example like this, which does not require any uploaded data. And this is based on pure coding, but yeah, usually it will take some time to wind up the space. Last time when I showed it, it worked, so we can see. But in general, the idea was if you find the original video, because this GIF is cut off, you can see that indeed you can upload dataset, write the question, and then it generates the code really fast. Let's see if it works. I don't want to spend a lot of time on this because it can sometimes time out because of Cerebrus API unavailability or something with the credits. Yeah, I believe today is the day. Okay. But in any case, the idea is very simple, that it is a very fast way to automate all this process. You just pass a prompt, your question that you want to know about the data, and then everything else, the whole generation process is automated for you. Basically, the model will generate code cell by cell until it reaches the final answer. And that's that. And you don't need to do anything during this process. Now, meanwhile, I'll just jump to how we created the training dataset for our Jupyter agent models. So we kind of wanted first to figure out how we can get the real notebooks and real datasets. And you all should know well Kaggle, that they use this notebook format a lot, and it's a great source actually to retrieve this kind of like decent quality notebooks that revolve around the idea of analyzing and processing data sets. You would see that a lot of notebooks that people publish there actually focus on those tasks. And what we did eventually was first to get Kaggle datasets and then get real data, which are real like notebooks kind of, and then we get Kaggle datasets which were used in those notebooks. And then we extract kind of question answer pairs about those datasets, and then we generate notebooks. So now let's dive a bit deeper step by step. So there is this dataset called MetaKaggle, which involves all of the notebooks, and it is regularly updated with snapshots from Kaggle, and it contains indeed all the notebooks that were published on Kaggle.
Hannah,
And
Hannah, I
we
don't want I don't want to interrupt you too much here, but we just have one more minute for this call, and then we're going to bleed into another call. So I just want to give you a heads up that we may have to cut this a little short. But
okay.
yeah,
Yeah,
just be
we can
aware of that.
skip all this part. That's no
Cool.
problem. So yeah, the idea is we have the notebooks, we generate QA answers from them. So we have dataset and then questions. And then we generate the notebooks which are supposed to answer those questions, which look like this. And we generate like 50K synthetic multi-turn notebooks on which we train later our models. And then we can see like in these columns on the yellow, they give us a now already bigger boost in performance, especially either score. And this is a very small open source model, which before that was not really strong on this task. Thanks to our custom scaffolding and additional tuning, you now can host locally this model, and it is more adapted to this task. And yeah, we just use supervised fine tuning, nothing really special. And this was done in not a lot of time. There are definitely more steps that you can do there. We can expand the data set, we can try reinforcement learning distillation, all the other stuff. But it's already quite impressive what we managed to do in a span of roughly 2 months of data generation and training. And it definitely shows that it is possible to take any model, any small model, and make it into this powerful Jupyter agent LLM, which is able to automate this process completely for you with high efficiency. So to cut this shortly, there is all resources we have. We have them openly on Hugging Face. We have the blog. We have a GitHub repo to reproduce the dataset generation hosting, Jupyter agent. We have the demo, which I showed you now. I hope the API will be fixed soon. And then we have the synthetic dataset that we use for training the models, which are available at the model collection. So yeah, this is how the dataset looks like. Feel free to dive deeper into them. But yeah, basically this is it. Everything is accessible on Jupyter Agent organization Hugging Face. So I can send you the slides link and then I can share more information with you later. Or some questions.
That's amazing, Hannah. Yeah. Please, if you could share that link to the slides, I will post it with the YouTube video on the Jupyter channel. This is really cool. I know that we got to see a little peek of it a couple of weeks ago, but this is awesome. I know we're bleeding into the other call. If we could just borrow like two or 3 minutes for questions from that call, if folks are cool with that. I'd love to open it up for anyone who wants to ask a question. Keep it short, but if you have a question for Hannah while she's here. Yeah, thank you, Hannah.
Yeah, thank you for hosting. I sent this link to the slides. And
Perfect.
Yeah.
Perfect. Do you have any questions for Hannah right now?
I'd say like not really a question, but I probably will have a ton of questions.
Yeah.
Because I've been following this space pretty closely recently, Hannah, and like that's why I sent you the link about the recent like Google research work. But
Yep.
maybe I can follow up and ask you a number of questions. Like, I think in my mind, like just kind of thinking about how this fits into maybe Jupyter strategy long term. I was talking to Fernando a little bit last week, Zach, and saying, hey, like there's a space coming up around like getting agents that do, specific things that are helpful to notebook users. How do we start thinking about like making sure that we understand that space, one, and two, we end up with some story to be able to, help even the local users and the remote users with these agents, right? So, I think that's kind of my perspective on this. The reason I want to learn a lot more about this is I feel like the future is going to be very kind of asynchronous and like there'll be a lot of assistance. And I think for us to start think about the kind of more the backend component where the assistance is actually like triggering and inference is happening to help users, I think it's good for us to start to think about that and connect all the dots. So thanks, Hannah. I appreciate it.
Yeah, thank you, Hannah. And maybe the one question, small, short question I had too was it looks like you tested this a lot on full notebook generation. I'm curious how how these models and this scaffolding works with like someone's already halfway into a notebook and we plugged it into something like Jupyter AI. Is it optimized for also just kind of interactively building from a starting place? So does it consume notebooks as input as well, or is there a way to feed that in and then use that to kind of iterate in a notebook in real time versus just full notebook generation? Like have you guys explored that much?
Yeah, thank you for the question. This is a good question. I would say it depends. It depends on the model. It depends how big the model is. Some models support long context, for example. They can fit these big notebooks into their context. But for
Yeah, makes
example,
sense.
the one that we used for big one, not that big of a context. That's why we do it kind of cell by cell fashion. And we use those remote sandboxes. But for example, like tools like Google Colab, they also operate on this kind of cell level. I'm not sure how they pass the context, for example, in their tools. They probably would have access to the whole notebook. And if they use Gemini, Gemini has huge context window, which enables them to process this in a more efficient way. I would say, yeah, if you pass the whole notebook, it's always better. There is more information. But it also really depends on the model that you're using. Maybe the best approach would be, yeah, taking some open model and trying to customize it, maybe train it yourself. Or, like we did basically this mini pipeline to adapt the models better to this task. Because out of the box, they're used to Python, just generating Python scripts and this complex algorithm. But something about analyzing the data, merging, they can do that, but they don't really treat it in this interactive Jupyter setup, especially,
Yeah, that's right.
with the code commentary and explanations.
Yeah, that's right. That's right. Really cool. Okay, I want to respect the next group. So thank you, Hannah, for your time. Really appreciate it, and for the demo. It was great. And I'll try to spend some time today, if not tomorrow, getting the demo posted on our YouTube channel with links to your slides.
Yeah, thanks a lot. Thanks a lot for hosting.
Yeah.
Have a nice meeting further.
Thank you. Thank you.
Thank you. Cheers, folks. Thanks, Anna. Bye-bye.
Yeah, cheers. Bye.
Thanks, Zach. Just a quick question. Should we stop the recording and restart it for the front end call?
Oh yeah, sorry about that. Yes,
No
yeah,
worries.
totally forgot.